Good morning, one and all. Welcome to the session on data mining. We have been looking into the unit 1 of data mining, where we understood some concepts in the pre processing methods. So, when we are trying to pre process data, we can see understanding of the data first is required before we try to pre process it. So, we started with the basic understanding of what data mining is and how it is used for gaining knowledge from heaps of data. We have seen that data cleansing is part of pre-processing, and cleaning up of data requires understanding of errors in data. And we have completely seen some methods that can erase the errors out of data. And from those clean data, we are going to start with the mining process. Before we set out to mine, we are going to look into some basic understanding of the data to see if the data is relevant or not. So we looked into some methods called as data integration. Data integration helps us to combine different data sources, heterogeneous data sources, into one particular source or a warehouse. To create this warehouse, we have seen that instead of storing the entire every bit of data inside the warehouse, we have consolidated some of the data, aggregated some of the data, and stored it inside the warehouse. And we have also seen methods such as numerosity reduction, dimensionality reduction, and data compression when we try to integrate data. That gave us an understanding of which attributes were important and which were less important for the task that we are planning. With that idea in mind, we have got some important data alone moved into the data warehouse. Once this data is available in the warehouse, we are going to start analyzing that data. So, our next step is to analyze the data. This analysis is done prior to the data mining task, because this is a very primitive understanding of the data before we even perform the mining task. These primitive analysis involve certain statistical functions. So basic information gathering or aggregation is done through statistical methods to help us get an overview of the data. So when we apply some statistical methods, we can get the bird's eye view of the data that we have in hand. And with that intention and perspective, if we can apply the right kind of data mining algorithms and on that data, the result of mining would be very effective. So we are going to try and understand the data in hand using some methods. So we have seen data cleaning and data reduction. The next is called as data transformation, under which we will also see discretization and binarization, and we will see the measures of similarity and dissimilarity in data. Why should we transform data? Why is a transformation required? Why should we understand the similarity in data? The more understanding we have of the data that we in hand, the more effective algorithms we will be able to choose. So instead of choosing a basic decision tree based classifier, I might choose a neural network to perform data mining for me. So it depends on the algorithm that I choose. The algorithm that I choose delivers some output called as knowledge. So if I choose the right kind of algorithms, I will be able to mine out the right kind of knowledge. To pick out which algorithm I can use for data mining, a basic understanding of the data is required. So we are going to understand some basic similarity and dissimilarity in data before we proceed further. So to understand this similarity and dissimilarity, we will have to again understand the types of data. We have already seen this, the primitive data types. But when you consider the entire data as a set, we can consider the data to be presented in the form of records. This is our commonly used data format in which we represent the data in the form of a matrix. It can either be numerical or it can even have character values. So a record is a two-dimensional structure. The one we call it the relational database is the typical example of a record. Record is just one form of data that we can deal with. Apart from record, some examples are shown here. So I have seen certain documents, certain transaction data. All of these are represented in the form of a matrix. This is called as transactional data. So for every transaction, you enter one particular row in the database. This is a relational database system. So when you represent the student information or the attendance information, the marks information, uh, anything that we can think of, it usually comes under the relational or the record based type of data. Apart from this, we also have another type of data called as the graph and network data. It is very difficult to gain an understanding of the graph or network data, and still there are not much more methods available for pre-processing graph and network data. So it's still in people are still trying to develop methods for analysis of this kind of data. The example for such graph and network data is the most commonly used World Wide Web. When you think of www or the World Wide Web, it is nothing but a collection of hyperlinked documents. So each document is connected to another document using a link structure. So if a web page is considered to be a node, then the hyperlinks out of that particular node is forming a network of documents, such is called as a graph or a network data. And we also have social media, and we can even represent the molecular structures using graph or network data type. And in such data sets, we cannot apply the basic statistical methods or the normal data mining methods. Most 95% of the data mining methods are applicable only on relational databases. So we are still in the process of finding out methods or inventing methods that can help us work with the graph and the networked data. Apart from this, we also have two other types of data. One is the ordered data, or it is also called as the time series data. So you have a sequence of events happening and it is being recorded, and that event has an order of occurrence. The order of occurrence is very important in such data. Such is called as an ordered data. So you can have video sequences, you can have a genetic sequence. All of these are forms of sequences which inherently have some order. Now, this ordered data can also be used for mining, but we have developed certain methods that can help us do the analysis on ordered data, which is called as time series prediction model. We will look into time series prediction model in unit 5. So we will have a glance of what time series prediction is. So this deals with data which are ordered across a time scale. And apart from this, we have spatial data, multimedia data, and image data. And still, we have not come up with methods, data mining algorithms that can help us with that type of data. So, for now, we have models or methods that help us work on relational databases and ordered data sets. And in the case of structured data, all these are structured data. There are other forms of unstructured data in the form of flat files, text files, video. All of these are unstructured data. So in structured data, the data has a dimensionality. The dimensionality of a relational database gives is the number of rows across the number of columns it saves. In a graph structure, it is the number of nodes and the number of links. So any structured data has a dimensionality. And when we talk of dimensionality, we will naturally have the problem of curse of dimensionality. In the sense, if you have very high dimensions in your data, then you will have to choose your data mining algorithm accordingly, because most of the data mining algorithms find it difficult as the dimensionality increases. The problem the data mining algorithms face because of the large number of dimensions is called as the curse of dimensionality problem. And when you have very large databases, sparsity becomes a problem too. Sparsity means the data is very less for certain attributes, or you have lot of incomplete cells in most of the columns, or in attributes. Most of the attributes are, we are not able to find the completeness in data, such is called as sparse data sets. In sparse data sets, the mining becomes even more difficult because the understanding of the behavioral pattern of the data changes as the data becomes sparse. So we do not know how much weightage each of that data carries. So unless you weight each of the column attributes, it is difficult to understand the relationship between data. And we also have to look into the resolution and distribution present in the data. Resolution means how do we identify patterns on a scale. So I can see, if I look into your attendance, the data that I have gives me a resolution at fortnight. So for every fortnight, I have a consolidated report and my resolution is a fortnight. If I look further, the day-wise attendance is not available in the summary sheets. It's available only in the faculty register. So that gives a higher resolution, or I can provide a day-wise resolution only in the register. And I can drill down deeper and find out subject-wise attendance from multiple faculty registers. So that is even a higher resolution, which gives me subject-wise attendance of a student. So that resolution, as the resolution increases, the volume of data that has to be stored also increases. And to understand data, we also need to understand the characteristic of distribution in the data, whether it is centrally distributed, whether you have a very closely knit data, or is it very dispersed kind of data. There are certain measures we are going to use to understand the centrality and dispersion of data. That depends on the type of data that we use. So we have seen what data objects are, and we have seen different types of attributes. One is a nominal, binary, and numeric attribute. So the measures of centrality and dispersion are going to be different for nominal, binary, and numeric data. So we will look into some of these measures that can help us gain better understanding of the data we have. So these types of data we have already seen in the previous class. So we have seen that we need some statistical description of the data. In statistical description, it is used for gaining some better understanding of the data. It gives a primitive analysis of the data. So in statistical description, when you statistically try to describe a data, there are two aspects of the data. One is the central nature of the data, called as central tendency, and the other one is called as the dispersion in data, or the variation in data. We are going to use some methods that help us identify the central nature and some methods that identify the dispersion in data. And when we try looking into these aspects, we might use some plots also. So graph structures we will use, some formula we will use, all statistical methods we will employ in understanding the central nature of data and the dispersive nature or the variation in the data. The first measure of central tendency that we use is the mean. It is very common. When I say central tendency, I should understand that I'm trying to get what the data is and what is the central nature of the data. So, mean gives a very vague idea of how central the data is or around what point the data is surrounded. So we can either use the formula x bar equal to 1 by n sum of all xi values, or it can be denoted as mu sum of all values divided by n. Both mean the same thing. Now if I have a weight associated with the data values, I might use the weighted arithmetic means, which is given as x bar sum of all the weights, product of weight and the x values divided by sum of the weights. So this gives me a weighted mean. All the CGPA that you calculate is based on weighted mean. And we can also use the value median. Median is where you group or you first sort out all the data values and then identify the central element in the data. So you sort the entire data, divide them into groups, and after grouping that data you find the one data element which is central in nature. That is called as median. A mode is the data that repeats itself most frequently. That is called as mode. Any data that you have can be unimodal, bimodal, or trimodal. In the sense, it can have one mode or two modes or even three modes. And there is a relationship between the mean, median, and mode in most of the data. Mean minus mode equal to 3 times mean minus median. So this gives a basic nature of the data. So once I have, if I look into the mean, median, and mode, I can see how well the data is distributed. So what is the central theme of the data? Around what point is all the data located? All this I'll be able to see. How much of repetition is there in the data? All this I'll be able to see with the mean, median, and mode. So with this I can identify whether the data is symmetric or skewed. In the sense, if mean, median, and mode of the data are in the same point, then it means that the data is symmetric. Imagine, I'll give you an example of symmetric nature. Uh, Take the average value of marks or attendance in your class. If you look into the attendance value, average attendance value, say it is 70 percentage. That is the mean value or the average value. Now the median says that there are equal number of people having attendance less than 70 and having less attendance above 70. Is it possible? When I say average attendance is 70, there are students with very low attendance values 10 and 12, 30, etc. But I don't have lot of people above or below that value. So it somehow balances and I get an average value of 70. Not, it doesn't mean that most of them are above 70, or I cannot assure that there are equal number of students with above 70 and below 70. So the median value may not be 70 if the mean value is 70. Is that clear? The mean gives a balanced nature, whereas the median tries to find out based on how many samples the data is occurring. So that is the median. And mode is the number of samples or the values that are repeated frequently. So if most of the students have the value 70 as their attendance, then the mode will be 70. But it is not practically possible to have this symmetric kind of data because the variation in data is going to be heavier than that. So if this is not possible, this is called as symmetric data. The other form, when you cannot achieve this, is called as skewed data. Now this is an example of positively skewed data, where the mean is 70. Imagine with our example, the mean is 70, but you have lot of people below the average 70, and you get the value 70 as average because there are 4 or 5 students whose attendance is 95%. Because of that, when you calculate the class average, it becomes 70, but the number of people having attendance above 70 is less than that. Is that clear? So the median is less than the mean, and the mode, the value that repeats itself frequently, is somewhere around 65. It is even less. Do you see? This sort of skew in data is called as a positive skew. The mean value is high, the median and mode values are lesser than the mean value. Such is called as the positive skew in data. And if I imagine a negative skew, the mean value is something, the median and the mode values are higher than that. In that case, I can call it as negatively skewed data. So, if I don't have a symmetric data, my data mining algorithms might not work properly. So first I need to understand whether my data is skewed or symmetric. If there is a skew in data, we will have to remove that skew, make the data symmetric, and then try to apply data mining algorithms. That is the objective of understanding the central and dispersive nature in data. And for dispersion, we have already known the variance and standard deviations are the common measures that are used for dispersion, identifying dispersion. We can also use plots such as histograms or a quantile plot. You will not be asked in your examination what these are, and it is not available in your curriculum also. I'm just giving you an idea of how you can measure dispersion in data. You can either use a histogram, a quantile plot, or a QQ, a quantile plot, or you can use a scatter plot. A scatter plot is the most easiest form of identifying a trend in the data. So we have already seen what negatively and positively correlated data is. If the data is correlated, then we might have to consider of applying data mining algorithms after removing some of the correlated attributes. And this is a sample of uncorrelated data. This also we have seen in the last session. Now I have understood there is some skew in data. I have understood there is some correlation in data, and I am trying to remove all of this. Apart from this, is there a central nature in data? So that I have to measure before I even apply the data mining algorithm. So some methods or some measures are used for identifying the similarity and the dissimilarity in data. And these measures depend on the data type. A similarity can be a measure of how much alike two different data objects are. So if you have the value to be very high, then it means that the objects are more similar to each other. And if the dissimilarity is very high, it means they are very different from each other. So I can put them inside a range of 0 to 1. 1 gives a value that they are very similar or exactly the same, and 0 say indicates that they are exactly the opposite. Okay, so such is called as similarity and dissimilarity. In the case of numeric values, I can just take the distance between the two numeric values and say that much of dissimilarity is there between the two data objects. But it is very difficult for me to identify how much of similarity and dissimilarity is available between other types of data objects. So for numeric variables, it has been easy. For other types of data objects, how do I consider this similarity and dissimilarity? So this is a data matrix. I can represent the form of dissimilarity for numeric values using the distance. So I can use a distance measure between any two given points A and B with all types of values. So I've got n data points. The distance between each of these n data points, numeric data points, is given using the dissimilarity matrix. It's going to be a triangular matrix or it's a symmetric matrix because the rows and columns below the diagonal will be the reflection of the rows and columns above the diagonal. So it's a very symmetric matrix. Dissimilarity matrix will always be symmetric in nature when we consider numeric values. We will look into how to form this dissimilarity matrix. So for numeric values, we will see what are the distance measures used, and for nominal values, how do we calculate this distance, and we will see how to calculate this distance between 2 points for ordinal variables, character variables, etc. Okay, the first type of data we will see is a nominal variable. The nominal variable is where I have a set of values that the attribute can take, and there is no inherent ordering in the set of values. So a color, red, yellow, blue, all of these do not have any order of preference, or they don't have a scaling or ranking, but the data object can take only these four values. Such is called as a nominal variable. The first one is method is finding the number of matches. So if I have between two different attributes, say for example I have the representation of two students and their favorite colors. So I can have red, yellow, blue and green as values that the favorite color attribute can take. So the distance between the two students or the similarity between the two students depends on the number of matches. So if my first favorite color is red, and it is red for 5 number of people, then I have to find out the total number of people in the class, and out of 60 people, 5 people have got the most favorite color as red. So that becomes the similarity in the class structure. That is called as simple matching. The second methodology is to create a contingency table. I'll tell you what a contingency table is. Now the contingency table indicates it is conversion of the same into binary attributes. So I'm going to convert for, I can use the same thing for binary attributes also. This binary attributes, it can take the value of 1 or 0. So in a class, you can think of the binary attribute as people who have above 75% is one characteristic, and people who have CGPA of above 7 is one characteristic. So whether it is based on whether it is yes or no, I can take the value, binary attribute value, to be 1 or 0. So in that data of the entire class, I calculate the number of ones for above 75% and above 7 CGPA and take it as the value Q. So it should satisfy both of my constraints. So that value is given as Q. If it doesn't satisfy both of my constraints, it can be noted as T. So this entire class has got P students, out of which Q number of students have both attendance above 75 and CGPA above 7. Some of them have attendance above 75 but their CGPA is less than 7. So likewise, I construct the number of students are falling under each category. This table is called as a contingency table. Once I create this contingency table for the class, I can see if they are symmetric variables. Say for example, symmetric variables means both above 75 and below 75 will have the same preference. It is not so. So I cannot use this. If it is symmetric, say for example girl and boy, the gender if I take, then the variable becomes symmetric. For such symmetric binary variables, the distance between the two variables is calculated as d of ij given in the first formula, r plus s by q plus r plus s plus t. This can be applicable only for symmetric variables. Once I calculate the distance, I can put it inside the dissimilarity matrix of comparing two different objects. And if the variables are asymmetric, then dij is equal to r plus s by q plus r plus s, which is given in the second formula. And these two are dissimilarity measures, or the distance between two different objects. If I want to calculate the similarity, it is called as the Jacquard's coefficient. For asymmetric binary variables, it is given in the third formula. Similarity value according to Jacquard between two different objects I and j is q by q plus r plus s. Clear? You will be asked to explain what is a similarity matrix and what is a dissimilarity matrix. You will not be given problems to solve on these. Okay. Now the same can be applied to binary variables. This is an example. I think we can look into the example in the next class. With this, I will stop now. We will look into the dissimilarity matrix for other types of binary variables, and we will look into some examples for numeric and binary variables in the next session. For now, I will close. Thank you one and all. Stay home, stay safe. Looking forward to seeing you all. Thank you.